Now dear students, let's say in our circuit we have an I2C or a PWM or some servo is operating, and we want to analyze how a controller is interacting with the servo motor, or if a controller is generating PWM, the pulse width modulation, then what is the shape of the signal, or if we have any analog value, then how we can read those values. Like if it's a digital signal, if our Arduino controller is communicating with another Arduino controller using the UART protocol or the I2C protocol, then we want to see different types at which time, what level of signal, with how much duration, at which frequency is transmitting between both the microcontrollers. For that, in the Wokwi we have the tool that is called the Logic Analyzer. So if we scroll down, and you can see over here, it's a Logic Analyzer. If you click on this, let's drag over here. It has an 8 channel of channels. It means that you can at one time check 8 types of different signals in the Wokwi Logic Analyzer tool. So for that, let's just save this, and let me just connect pin number 8 to D0 of the Logic Analyzer. So what will happen, whatever the state, when we start simulating, whatever the state the pin number 8 will have will be given to this Logic Analyzer. And the Logic Analyzer, when we start the simulation, the Logic Analyzer will start to record the different changes in the state of the voltage level at the pin D0 of the Logic Analyzer. Now the next thing is, if we let's just toggle this pin high and low. For that, we have just studied that how we can do that. First thing is we have to specify the pin mode, and the pin number 8, let's give it an output, while in the loop, which is the code that is written in the loop will be repeated infinitely. For that, we can write over here digital write pin number 8, we will give a value high. Let's add a delay of about 200 millisecond. Then let's write again digital write pin 8 low, and after writing this, let's again add a delay of 200. And in this way, what will happen when the microcontroller starts to execute this loop, it will write high, means 5 volt on the pin, and after a delay it will again write low value or the 0, and then after a delay it will again write, after a 200 millisecond delay it will again write high. So this will be continuous, so it will be generating high low signals continuously. So let's just save this, and let's just run the simulation. And now the simulation is running. Now you can see that it's telling the number of samples it have counted, it has recorded. What is actually happening, that this code this code in the while loop is actually toggling the pin number 8. So you can see over here that it's green on off LEDs. It's actually the signal that is generated by this the code in this loop function, and the Logic Analyzer is recording all those values of that with respect to time, when the signal was high, when the signal was low, that was the duration between the high and low of the signal. So you can see that it's counting. Now how can I see the wave shape? The next question is that in the Logic Analyzer we are recording all the logic of the function that of the pin on which we have connected the D0 pin. Now we want to see the wave shape. For that you have to, let's just stop this, and you will see that a file is now downloaded that says Wokwi Logic.vcd file. In order to view this VCD file, we need another tool that is the what I prefer to use is the pulse view tool. Over here, go to this link and download your pulse view tool. I have already downloaded this tool, so let's just launch the pulse view tool. So let's click on open. Now it's just initializing, launching, it's okay, click OK. Let's just minimize this. Now as you see that when I have stopped the simulation of Wokwi, a file with the name Wokwi Logic.vcd is downloaded. So what I will do that I will import that file over here in our logic analyzer. So let's click over here, click on this import value change dump file data. Then this file I had is downloaded in the download. So click on this file, hit open. Now it will pop up a window in which just change the downsampling factor to 50. That is sufficient for most of the signals that we will be using with the microcontroller. So let's click OK. Now you can see that it says logic D0, means that this is the wave shape that is shown over here is actually recorded as the D0 of the logic analyzer. So if I click on this, you can see that this is the wave shape that is recorded at the D0. So hopefully you have understood my point that how you can check the wave shape or the signal that is generated by the code in the microcontroller. In the pulse view, you can also zoom your wave shape, and over here it's the time. You can also check at from which time to till which time it's on, and it's at which time duration it's off. This is the high side and this is the low side. Means when we write digital write high, then this is the green line shows the high, and when we write digital low, this red line is showing the low of the signal. So in this way you can view your the wave shape of the signal that is generated by the code. Let's say if I change the time and I write over here that it should be high for 50 millisecond and low for 200 millisecond. Let's save this. Let's run the simulation again. Now it's again you can now see from the blinking of the LED that it's on for a very little time, and it's calculating the samples. So let's just stop this. Whenever you click on the stop simulation, it will download an other file of the wave shape. Again similarly, right click, import value change data, and this is the file we have downloaded. Again click open, change the downsampling factor to 50, click OK. Now you can see that in the code we have specified that high should be for 50 millisecond and low should be for 200 millisecond. Now you can see in the code in the pulse view that, let me just drag this over here. You can see that again it's there. You can see that it's leaving high for a 50 millisecond, and then after that it's going down for a 200 millisecond. So in this way you can view your pulses that you want to the logic of the signal you want to check into your circuit while doing this simulation. So hopefully you have understood the complete process that of using the logic analyzer. There are also different settings of the logic analyzer that we'll be studying in the future when we encounter different situations. for analyzing the signal. So hopefully you have understood how to add the logic analyzer. Simply go to this add and click on the logic analyzer that will be added. Wire up the logic analyzer with the signal that you want to analyze and just click on the simulate, and then when you stop, this will download a file that is a VCD file, and you can use pulse view or any other viewing software. Then import the VCD file, boom, that you have the logic of the signal that is downloaded. So hopefully you have understood the use of logic analyzer.